Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The two structures shown are cyclic forms of a sugar, appears to be fructose in furanose form, connected by an equilibrium arrow. They differ only at the anomeric carbon, C2 in fructose, where the OH group is on opposite faces in the two structures. Moving on to the next step. The two structures differ at only one stereocenter, the anomeric carbon, while all other stereocenters remain identical. Two compounds that differ at one or more stereocenters, but not all stereocenters are diastereomers, not enantiomers. Enantiomers would require inversion at all stereocenters. Since only the anomeric center differs, these are diastereomers, specifically, they are anomers, alpha and beta anomers. Moving on to the next step. The interconversion of alpha and beta anomers of a sugar in solution is called mutarotation. This process involves opening of the ring, breaking the CO bond at the anomeric position, rotation, and reclosing, which results in a change in optical rotation over time until equilibrium is reached. And for the final step, options A and B are incorrect because the structures are not enantiomers, they are diastereomers, anomers. Enantiomers require mirror-image relationship at every stereocenter. Option D is incorrect because the interconversion does require breaking and making bonds. The ring opens and closes at the anomeric carbon, breaking and forming a CO bond. It is not merely a conformational change. Option C correctly identifies them as diastereomers and names the interconversion as mutarotation. Therefore, the correct answer is C. Therefore, the correct answer is option C.